Okay, so we're going to be changing forms today. So to go from factored form to standard form, it's pretty easy to do that. We would just distribute, right? So I'm going to show you how to do it using this area model, but it's really just distributing. So over here, I'm multiplying 3x times a positive 2, and then an x squared, and a positive 3x, and a positive 4. And so what they want you to do is they want you to multiply each one of these out. So 3x times x squared is 3x to the third. 2 times x squared is 2x squared. 3x times 3x would be 9x squared. 3x times 2 is 6x. 3x times 4 is 12. And 4 times 2 is 8. Sorry, I messed up. 3x times 4 is 12x. And 4 times 2 is 8. Now just group your like terms together. So do I have anything like 3x to the third? I don't. So that leaves me with 3x to the third. Next, do I have anything like 2x squared? Yeah, 9x squared, right? Those are like terms. So if I add those, 9x squared and 2x squared gives 11x squared. Next, do I have anything like 6x and 12x? No, those are the only two. So I add those to get 18x. And then 8 is left over. There's nothing like it. It's my constant term. So what's the degree of f? Well, the degree would be a degree 3 polynomial. That's the highest degree term. And then C, what is the y-intercept? Remember, the y-intercept happens when x is 0. So if I plug in 0 for x, this term is gone, gone, gone. And all that I'm left with is the constant term, 8. So the y-intercept here would be 8. Standard form is really good at identifying the degree and the y-intercept. That's what standard form is good for. So again, I know if you're going to work this out, or me personally, if I had to actually find this standard form, I wouldn't be using this area model every time. I would just distribute, right? 3x times x squared, 3x times 3x, 3x times 4. Right, that's what's happening right here in this top row. 3x to the third, 9x squared, and 12x. And then in the second row, that's where they do 2 times x squared, 2 times 3x, 2 times 4. Right. But the area model, I guess, is kind of good to see it spelled out. And it's going to kind of help us in a problem later on to give you another example of how to work something out. 2, it says let g of x be equal to x cubed plus 4x squared plus 5x plus 2. Suppose that we know x plus 1 is a factor of x cubed plus 4x squared plus 5x plus 2. What does it mean if it is a factor? Well, again, if you think back to what are the factors of 16? Right, that could be 1 times 16, 2 times 8, or 4 times 4. So if I told you 8 is a factor of 16, what does that mean if it's a factor of a number? It divides evenly. And evenly is kind of a weird word to use there. A better one might be there's no remainder. If I divide by that, there's no remainder left. So here's how we can use the area model to find the factored form. So I know I need my total inside the box. The total needs to be x cubed plus 4x squared plus 5x plus 2. That needs to be the total. So if I need to multiply to get an x cubed here, like we had the 3x cubed here, x needs to get multiplied by what to give me x cubed? That would be x squared. Okay, well, if this is x squared, then this box, 1 times x squared gives x squared. But now my like terms are going to be here and here, right, just like we had before. So this is my x squared terms. I need it to total to be 4x squared. So if I've got x squareds here, that means left over has to be 3x squareds. Because these would combine to give me 4x squared, which is what I need. And so then what did I multiply by to get 3x squared? X times what is 3x squared? That would be 3x. And so if this was 3x, 3x times 1 would give 3x. And so this is my x of the first term. Well, I need that to total to be 5x. So if these have to total to be 5x, then that means this box here has to be 2x. And x times what gave me 2x? That would be just a 2. And then 2 times 1 is 2. And you see how that worked out evenly with no remainder. So what I've just got done doing is basically dividing. Inside the area model is x cubed plus 4x squared plus 5x plus 2. And this is what I had to multiply x plus 1 by to get this answer, which means the other factor would be x squared plus 3x plus 2. And this will factor again because this is a polynomial, degree 2. Hopefully you can look at that and know that factors to be x plus 2 times x plus 1 in factored form. If not, you need to do the a times c method to get there. And this answer is actually 4. So all the area model is another way to do long division or do synthetic division. So just very quickly, I'm going to review how to do those because I don't care which one you do, just as long as you know how to do one of them. So in long division, if I had x cubed plus 4x squared plus 5x plus 2, and I'm dividing by x plus 1. And here's how this works. I have an x. I want to have x cubed. X times what is x cubed? It turns out it's x squared. So see how I'm asking the same kind of questions I was asking here. And now then we distribute it. X squared times x is x cubed. X squared times 1 is x squared. And then when we do division, we change the sign so these become subtraction. That goes to 0. 4x squared minus x squared leaves me with 3x squared. Remember, there's an understood 1 there. And you can bring your other terms down. So bring down the 5x, bring down the 2. Now I've got x, and I want it to be a 3x squared. X times what is 3x squared? That would be 3x. 3x times x is 3x squared. 3x times 1 is 3x. But now when I do division, I have to change the sign. These become subtraction. That goes to 0, which leaves me with 2x. Bring down the plus 2. Now I have an x. I want it to be 2x. X times what is 2x? That's going to be positive 2. 2 times x is 2x. 2 times 1 is 2. Change the sign, so they become negative. Everything goes to 0. That means it factors evenly. And that's how you can do it in long division. Okay, then the last one is if you did synthetic division. So if I want to do synthetic division here, that's where we look at the coefficients. Synthetic division is really only useful if the known factor, or I say useful, it's super useful, it's more useful if the known factor here is x plus a number or x minus a number. How this is not a 3x or 7x. If it is, it makes synthetic harder. Or synthetic is not, you can't use it if this is an x to the second. Synthetic is only good for an x to the first, and it really works well if this is a 1 is the coefficient and any constant here that's not a fraction. So again, enough talking. Let's get to how to do synthetic. Write the coefficients of the polynomial. So I'm looking here. 1x cubed plus 4x squared plus 5x plus 2. So I'll write down the coefficients. Now then, if x plus 1 is a factor, then that means there's a root at -1. So I'm going to put -1 up here in my little box. And let's do the synthetic division. We bring the first number down. We take this number, multiply it by what's in the box. 1 times -1 is -1. And then combine. So 4 minus 1 is 3. 3 times -1 is -3. And then combine. 5 minus 3 is 2. And then multiply. 2 times -1 is -2. 2 minus 2 is 0. So I've got a remainder of 0, which means this is my constant term. This is my x to the first term, x to the second term. So this is 1x squared plus 3x to the first plus 2 as my constant. So again, you've seen 3 ways to do this: area model, long division, synthetic division. Okay, so I'm looking back here, and I worked out this whole thing and talked, and I didn't record it. So let's just talk through it. I know the answers are already, never mind. Yeah, I'm just going to talk through it. I'm sorry. Hopefully you guys can figure out what's going on without me working it out. I'm mad at myself at the moment. 4, this was the factored form. Could it factor any further? We talked about this could factor. So x squared plus 3x plus 2 gives x plus 2 times x plus 1. So this is the factored form because x plus 1 happens twice. Here I have x plus 1 squared plus 2, or times x plus 2. The next question, what happens when g of x equals 0? Well, so all we're saying is y is 0. Well, what happens when y is 0? We're getting the x-intercepts, the roots, the solutions. So if I plug in 0 for y, that gives the x-intercepts. We should get x plus 1 equals 0, x plus 2 equals 0. But because the x plus 1 factor happened twice, it has a multiplicity of 2 when I solve it, or this one has a multiplicity of 1. So just to review, what's factored form good for? Finding the roots, the x-intercepts, whatever. Okay, here we're doing the area model again. So let's just talk through how we're supposed to do this. Try to do this on your own without looking at this, see if you can do it. So I know I'm dividing by x plus 3, so I'll fill that out here. And I know this first term has to be x cubed. So again, think about on the area model, this has to be x cubed. These have to combine to be 4x squared. The next two have to combine to be 5x to the first. This has to be the constant 2. So as I'm working this out, if this has to be x cubed, x times what would give me x cubed? That's x squared. So then x squared times 3 was 3x squared. And now then I know these need to be 4x squared. So I need 1x squared left. So this has to be x. Right, so I'm basically just doing division, working backwards, just like we did on number 3. Once you get to the end, though, you'll see the constant term is 6, which is not the 2 that it's supposed to be. So what does that mean if it doesn't match what it's supposed to? It means that this is not a factor. X plus 3 is not a factor of this polynomial because it didn't divide evenly. And what I was explaining before was you're not really doing division, though, here. You're kind of working backwards, which is a form of division. But we can't say the remainder is 6. What we can say is we're supposed to get a 2, and we got a 6 instead. So it doesn't give the original expression. So if you're working these out, me personally, I wouldn't use the area model much. I do think it's a good representation to look at it and know how to do it. But I would be more concerned with, do you know how to do synthetic division? Can you do long division? I think those will be a little bit quicker and more efficient for you on the actual exam. This is a good learning tool and kind of seeing it from a different perspective, different point of view. Okay, I'm fixing to put up the notes here for 2.7. So they talk about factored form and standard form of a polynomial. What's good for what? It's very similar to a quadratic. What's a standard form of a quadratic good for? What's factored form of a quadratic good for? It's really the same things here. And then learning target 4, knowing a 0 or x-intercept gives you a factor. Dividing by a known factor helps you find the remaining factors or identify any remaining zeros. So yeah, take time to write that down and then try to check your understanding. You might want to go ahead and pause the video. I'm going to put the answers up here for the check your understanding now. Okay, so here those are. We can see this is an x squared times x times 3x. That's going to give me a degree 4 polynomial. And then what are the y-intercepts of the graph? Remember, we can find the y-intercept by just multiplying the constants by each other. So that's negative 2 times negative 2 times 6 times negative 1. We had to multiply negative 2 twice because it's raised to the second power. So this parenthesis is really happening 2 times. So the y-intercept is negative 24. They want to know, is x plus 2 a factor? So if you do the area model, you could see you get negative 28 at the end where you're supposed to get a 3. So it does not work out as a factor. It doesn't go in evenly. You could also test this by doing long division or synthetic division. And if that last number doesn't cancel, or if it's not a 0 in synthetic, then it's not a factor. Let g of x be here, the standard form polynomial. Use your graphing calculator to find the real zeros. State their multiplicity. What do you know? So if you plug that in your calculator, you should see you have an x-intercept at negative 1. It says its multiplicity is 1, so it must cross there. You have an x-intercept at 3, so it must cross there. And so what that means is, if negative 1 is a x-intercept, then x plus 1 is a factor. And if 3 is an x-intercept, then x minus 3 is a factor. So then what they do is they just distribute these out, x plus 1 times x plus 3 to get this. And so I could also say this must be a factor. B, find the remaining factors and zeros. So they did it in an area model again. For me, I wouldn't do it that way. So let me work B the way I would work it out, so you guys can see. If I know negative 1 is a factor, then I'm going to do synthetic division with negative 1 up here in my box. Write your coefficients. Negative 1, 2, negative 13, 32, 48. Bring down the first one. Multiply. Combine. Multiply. Combine. Multiply. Combine. Multiply. Combine. So because this last one's a 0, I know it's a factor. So negative 1 works. And now I have a new, this is called a depressed polynomial. It has one fewer term because I've done the division. So now I would do synthetic again, this time of the depressed polynomial. But instead of putting a negative 1 in the box, I'm going to use the other factor that I know, which is 3. So if use the other x-intercept I know, which is 3. So I put 3 in the box. Bring down the negative 1, multiply, combine, multiply, combine, multiply, combine. So I got 0 again, which means that was also a factor. So again, this is my constant term, negative 16. I don't have an x to the first term, and my x to the second term is negative x squared. So this is my new depressed polynomial. So if I needed to find my other factors, what I'm saying is this factor is to be this times x minus 3, which I got from here, and x plus 1, which I got from here. That's my factored form. I'm looking for the x-intercepts, set the y value to be 0, and solve. So I know what this gives and this gives, so I'm really just setting this equal to 0 and solving. So if I move the x squared over, that's going to be positive x squared equals a negative 16. If I take a square root of both sides, now I'm taking a square root, so I have to do plus or minus. But this is a negative number underneath the radical, so I know it's going to be the imaginary unit. Square root of 16 is 4. So here are my other two factors. This is my other factor is negative x squared minus 16. These are my other two roots or solutions that are complex, which again makes sense why they're not showing up on the graph. And so then C, write the fully factored form. So negative x squared minus 16 will factor to be, just think about moving these over. That's going to be x minus 4i and x plus 4i. So the way you find the factored form here, move everything back over and make it say it equals 0. So x plus 4i equals 0, x minus 4i equals 0. Here's my factored form.